This next product, Face It, I think, rather than trying to use JavaScript in kind of a novel context, whether it's for facial recognition or ML or Internet of Things like these past two products, this is JavaScript at its core, using it for asynchronous event-driven programming. Face It is a really fun, really addictive game where users have to match in real time their facial expressions to an emoji that's rendered in front of them while they collect coins. You'll see the gameplay in action, and you'll get a sense for just how addictive and fun it is. So without much further ado, here's Face It.
Hi, my name is Mitchell, and my teammates are Jose, Anthony, and Nick, and we are the creators of Face It. Our goal for this project was just to make something silly and fun and interactive that you could do with your friends on the internet. And here you can see some of our colleagues and classmates demoing the game, and they're getting to do all kinds of crazy actions with their arms. So what we ended up with was kind of a mashup between Simon Says and what we call virtual bop it. In that sense, the Simon Says aspect is where, as Dan mentioned previously, where you need to match randomly selected facial expressions, and while doing so, collect these virtual coins that appear on your webcam feed. And Jose is going to tell us a little bit more about how those gameplay aspects work.
Hi, everyone. So this is our single player mode. This is one of our fellows who's demoing it. Now, the thing is, he has his hands on the coins, right? But he's not able to make them disappear or collect them, and that's because he's not matching that target emoji on the board. It's a happy face. He's kind of frowning. Now in this one, he's giving us a big grin. It's matching that one target emoji, and he's collected those coins, and he's going up for those next two. You see that over there. And how we do this is through two things: emotion detection and motion detection. Our motion detection works through an HTML5 canvas API. We map the video feed to the canvas, and then we gather image data and analyze it from there to see if anything's changed on the video feed. Now, the emotion detection happens through a library we found called CLM Tracker. It models a user's face, and it gives us emotional data output. This allows us to have a dynamic gameplay experience for both single player mode and multiplayer mode. And this is our single player mode in Mercs. You see how he has to change his facial expressions to match all of these new emojis and move around in weird ways to grab all those coins. Well, yeah, that's our single player mode. And now for our multiplayer mode, here's Anthony.
A user can navigate to multiplayer by selecting the face-to-face option in the sidebar. There, they can create or join a room by entering a name in the respective field. We use sockets to initiate the connection between players and WebRTC to keep this connection persistent. Multiplayer shares the same game functionality as single player, with the added ability to black out your opponent's screen by hitting the spacebar and spending a number of coins. Here, two players are facing off. One will hit the spacebar, blacking out his opponent's screen, and adding to the frustration of not being able to hit his target emoji.
Wait, hold on. How did you get to 45?
I'll now hand it over to Nick, who will give insight to our technical choices.
Thank you. So as Anthony mentioned, we used Socket.io as our signaling server to create our peer connections and also to relay any changes occurring in the game to other users. On the back end of our app, we used Express as our server and Postgres with SQLize as our database to maintain user persistence and store any game stats. We built the front end of our app with React and Redux. We needed to be able to display the coins and emojis depending on the current state of the game at any given moment. We also needed to make sure that, sorry, I'm seeing them play in the background. We also needed to make sure that both players had access to the same game information at any given time so we could have a true multiplayer experience. And for the emotion detection, as Jose mentioned before, we use the CLM Tracker library. We looked into several APIs, but at the end of the day, We wanted something that we could implement straight into our code so we can manipulate it and customize it to our specific needs. And that worked out better than relying on an external API. So we had a lot of fun making this app. We hope that you can visit it at faceit.herokuapp.com and try to make some more ridiculous faces than these. Thank you.
All right, that is a ridiculously good gameplay idea. I'm actually loading on my screen right now, and it's actually pretty hard to. Can we get a couple rounds of you, David? Yeah, I'm going for it. Do I refresh here? Yeah, just enter the number of rounds. Oh yeah. I guess I can't. The angry face going, but very cool. Very good idea. Very cool idea. Very cool idea. I like it. I like it. Yeah, it's so much fun.
Sorry, we're
having too much fun back here.
Yes, yeah, I muted myself. I was too busy watching you. Yeah, this game definitely we lost some time during code reviews because similarly I would just be playing it instead of giving actual feedback on the code that they've written. It's truly fun, and I love when students are able to use technology in a way that allows us to still engage with each other on what feels like a very organic human level. This is obviously a web-based game, but it involves players looking at each other's faces rather than simultaneously staring at a screen, and that just feels very wholesome to me.
Yeah, I really like. You almost forget about the technology while you're using it, and I think the best technology has that feature that you just start having fun, and then you forget about what you're actually playing or doing.